Hi, this is Darrell Lewis-Sandy from Mana. Welcome to the third tutorial video in our series about the physical quantity service. The physical quantity service is a GraphQL-based microservice that provides a utility to parse and extract physical quantity mentions from strings, to convert between units of measure, and to perform arithmetic with physical quantities in a way that respects their physical dimensions. This series of videos uses a Workspace service template which contains all of the lessons that we'll be working through. If you've been following along on our previous videos, you will have already created a copy of this template. If you haven't, take a moment now to clone your own copy of the Physical Quantity Tutorials template. In today's video, we're going to be working through the exercises in Lesson 2, Parsing with Constraints. If you open that knowledge graph, you'll see that it's been pre-populated with the kinds and functions that we're likely to use in the course of this exercise. We'll be creating the function parseObservedLengths, which, given an instance of an observation for which the value is the surface form of a length, will return the parsed physical quantity. Otherwise, it will return null. We're going to do this using the parse function. In our previous video, we saw that the parse function could be used to parse a surface form of a physical quantity and return the physical quantity structure. We focused on the first argument, which is just the string to be parsed. However, the parse function has two additional arguments, the system of units IDs and the physical dimension name. We're already familiar with the concept of a physical dimension from our first training video. But the concept of a system of units is new. Let's take a look at that before we proceed. The physical quantity service provides the system of units kind. The system of units kind represents the concept of a collection of units of measure and their associated prefixes that are commonly used together. If we look at the instances of the system of units kind, we see that the physical quantity service provides three by default: the MKS or metric system, the imperial, and an oil and gas domain-specific unit system. Each instance of a system of units has a unique identifier, a description, a collection of simple units of measure, a collection of unit of measure prefixes, and a collection of aliases. You've previously seen the concept of simple unit of measure. Simple units of measure are just the building blocks for unit of measure expressions. You've also seen the concept of unit of measure prefixes. Unit of measure prefixes can appear in unit expressions preceding simple units of measure to scale their value. Aliases provide a way of creating a relation between the symbol customarily used for a unit of measure and other possible representations. For example, when we look at the symbol for minute, we can see that there are alternate representations that we might encounter in everyday use, like mins, minute, and minutes. The parser uses this information to normalize the surface forms that it encounters during parsing. Now let's return to our tutorials workspace and try this out. So in addition to providing a source string here, I'm also going to provide it a system of units and a name of a physical dimension. So when I run that, even though 10 psi is a perfectly acceptable unit of measure, what returns is null because it's not a unit of measure in the metric system and it's not a unit of length. If I change this to pressure and run this again, it still returns null. But if I change this to the imperial system, it parses it, and we see that we have 10 psi and the expected factors. Now you have all the tools to do today's exercise. Remember, you're implementing the parseObservedLengths function, which should parse any surface form so long as it has dimension of length. Why don't you pause the video here and try to create your own implementation of this function, and I'll be right back with my own. Welcome back. Now that you've had a chance to work through your own solution, let me walk you through mine. I'm going to open up the function graph for parse observed lengths. So I know that I need the parse function and the projection function that are on the canvas. So I'm going to start by dragging those into my function graph. Parse and project. There we go. Now I know that if I connect these up the way that I did previously, where I wire the observation into the projection function, and the output from the projection function into the parser, and the output from the parser to the output of my function, I'll get a function that parses any physical quantity from an observation. That's not quite what I want. I want to make sure that it parses only observations of length. So I need to provide a physical dimension name for length. Well, let's look here. One of the functions here on the canvas is called length, which is just a constant function that returns the literal length. That's exactly the missing piece that we need here. So I'm going to open up my function graph again, and I'm going to drag in the length function. And I'm going to wire that into the physical dimension constraint field. Now the only thing that's left to do here is provide a implementation for the length function. And this is simple enough that I could do this using the Lambda assistant. All right, now our function is ready to run. Let's try it out. I'm opening the run dialog. I'm going to give it the airspeed and run that. Now, because airspeed is a velocity, we would expect that it returns null. And in fact, it does. So now let's select another instance. Let's select the altitude and try that. And run. And sure enough, altitude is a length, so we get the parsed value. Let's try one more. Let's try the distance to the runway. And there we have it, 45 miles. So it was that easy to filter the parse results so that the only physical quantities that were returned had dimensions of length. It would be equally easy to modify this function so that it only returned physical quantities that the surface form used units from the MKS system. And I'm going to leave that for you as a challenge exercise. That just about wraps it up for today. I hope that you had fun learning about the advanced features of the parsing function. In our next lesson, we'll be talking about unit of measure conversion. I hope that you'll tune in. If you enjoyed this video and want to learn more about the physical quantity service, don't forget to subscribe to the Mana Inc. YouTube channel